Hi, my name is Cassidy Volts, and I will be presenting on how to use biological control to restore plant communities. The target audience for this presentation are professionals in agricultural extension services. The key learning objectives for this presentation are to help you understand how biological control can be beneficial to plant communities and ecosystems, and to also learn about the different methods of biological control and how they can be used successfully. So for those of you who may be unfamiliar with the term biological control, what exactly is it? Well, biological control is an active method that is used to control invasive plants and insects by using their natural enemies. Biological control is a useful tool for managing ecosystems, and there are three main methods: importation, augmentation, and conservation. So, how is biological control beneficial in plant communities and ecosystems? Well, for starters, natural enemies can come in many different forms, such as parasites, pathogens, predators, or herbivores. These natural enemies are then used to reduce the number of invasive species in an area. Biological control is also beneficial to plant communities and ecosystems because there is no environmental contamination or pollutants. So now I want to show you a graph of how exactly biological control works. As you can see on the graph, there is the bottom axis, which shows the time, and the left axis, which shows the total population of a species. In order for biological control to work, the natural enemy or agent must be able to survive, reproduce, and maintain a steady population. Once they are established in the area, they are then able to start damaging and reducing the numbers of the invasive species. The damage threshold on the graph shows us that when the invasive species population is reduced, so are the number of the biological agent. This is because the biological agent, or natural enemy, is reliant on the invasive species to survive and thrive. Some of the pros of biological control include the fact that it is not as destructive as chemical applications, because it only affects the intended target. Biological control can be self-sustaining once the natural enemy population establishes and can then become a permanent solution, whereas spraying chemicals requires multiple applications every year. It is also cost-effective and a cheaper method than other management practices like using pesticides or herbicides. Some of the cons of biological control are that it is a slow process and can take several years for a natural enemy population to establish and start to make a noticeable change in the reduction of invasive species. Another con is that there is quite a bit of knowledge and background information needed in order to pick the best natural enemy for an invasive species. Biological control can only reduce the number of invasive species and not completely eradicate a population. It can also be unpredictable because some natural enemies fail to establish properly. Now, the first type of biological control is called importation, and this is the most common of the types used. It can also be called classic biological control, and it is the process of introducing a natural enemy into a new location and letting it establish so that it can maintain a stable interaction with the invasive species. An example of importation is the cottony cushion scale, which is one of the earliest examples of importation. There are two introduced species that are host-specific to the scale and use it to control its population. The Vidalia beetle and a parasitic fly both use the scale to lay their eggs inside, and then their offspring are able to feed on the scale and therefore reduce its population. Another type of biological control is augmentation. Augmentation increases populations of natural enemies that are already found in a landscape or area. It is important to know the timing of release for natural enemies when using the augmentation method, because some invasive species can be found in larger numbers during breeding or feeding times and seasons. This method is commonly used in gardens or for lawns. Japanese grub beetles are managed by using augmentation as a type of biological control. There is a bacterium called milky spore that is used by applying it to the area that is affected with grubs. When there is a high population of grubs, it helps the spread of the milky spore disease. This is because when a grub eats the spores after they are applied, the spores will begin to reproduce in the grub until it is dead, and then it will release millions of new spores to attack other grubs. The last type of biological control is conservation. Conservation is used to reduce factors that may be limiting the population and effectiveness of natural enemies. It also provides resources to create a suitable habitat and increase the number of natural enemies. Conservation is used when there is already a natural enemy that is adapted to the area. An example of conservation biological control are green lacewings. The offspring of the lacewings are predators of aphids and a great way to control them. So if your garden or greenhouse is infested with aphids, the eggs of lacewings can be purchased and then used in the greenhouse or garden. Lacewings are also attracted to pollen and nectar, so including plants that produce a lot of both of these would be beneficial. Next, I just wanted to cover one of the most invasive species in North Dakota's prairie communities. That species is leafy spurge, and it reduces the forage production on pastures because most livestock will not eat it. Since landowners are responsible for controlling the population of leafy spurge on their land, they often use multiple chemical applications to try and counter it. However, leafy spurge can start to build a resistance to chemicals, and this is why biological control can be beneficial. The images on the right show the spurge hawk moth caterpillar on the top, and below is the leafy spurge beetles. These species utilize the entire leafy spurge plant, including the root system, in order to reduce their population. When it comes to determining how to use biological control, the agent selection, or natural enemy, must be decided first. As shown in the previous slide, there are multiple natural enemies that can be used for invasive species. It is up to you to decide which natural enemy will be the most effective for your goals. Another thing to consider is the overall cost of the biological control. The first time introducing a natural enemy can be expensive, but once they are established, there is no need for more applications as opposed to chemical solutions. Lastly, choosing the method that is the most appropriate for the invasive species you are targeting. Now for a little bit of recap, I just wanted to ask a few questions. So first, how does biological control benefit the ecosystem? Well, biological control can benefit the ecosystem because it is environmentally friendly, cost-effective, sustainable, and controls invasive species, among other benefits. Next question, which method is the most commonly used? The most commonly used method in biological control is importation, which is also called classic biological control. Lastly, what is one example of a biological agent being used to fight off leafy spurge in North Dakota? There were two main ones that I mentioned, and they were the spurge hawk moth caterpillar and the leafy spurge beetles. Thank you for your time, and here are the sources I used to find my information about biological control and restoring prairie communities.